recorded. Means all the key material being delivered will all be recorded. Okay. All right, so just getting started again, just a reminder of the schedule there. But what we're going to talk about today is I mainly want to review the posted solution and then the next part of the homework. Tomorrow's class, we're actually going to get into the new material, right? But for today, we're just kind of reviewing everything. So you'll notice, of course, down here in examples and solutions, the solution for part one was posted. It went up around midnight last night, so you can download it and grab your copy. I highly recommend actually that you use this as a starting point for part two. Um, some students have done a great job on their part one, and if they really want to continue using it, that's fine. You can just build upon it. But we are going to be making some changes and whatnot. So I kind of feel that you might want to actually just get in the habit of taking the last posted solution. That way you can just focus on the new steps, the new things you're adding to the solution, instead of worrying about anything kind of nagging you from what you did in the last part, right? And then there's always going to be time to go back and rework and fix up, your own code from your own previous part. So it's up to you. You don't have to do it, but I think most students will find that that's a good way to go about it. Oh, by the way, this little text file I threw up here, after I posted the solution, it occurred to me that some students had emailed, they were really having a hard time with regular expressions. There's a limited amount of documentation online, although it's getting easier and easier to come up with a good regex, I find. But I wanted to show an alternative approach. So I'm not going to spend time looking at this particular file because I've incorporated it into the current version of the solution that I'm running right now. So, okay, besides that, what I have open right now, I have the instructions for all three. Part 1A, B, and then the new assignment as well. So I'm going to be referring back to this as we walk through the solutions. That's our first order of business today. All right, so here in the solution, right? So as the instructions say here, basically we're starting off with the models. Okay, we have just the three entities for now. We'll build on this as time goes on. So we have our customer class, the function type, our simple lookup class for the type of function it's going to be, and then the actual function itself, right? So quite a bit of detail was given here in terms of what's required and what isn't, and the data types. There's some pretty strong hints in the documentation that you were given. By far, of course, the most interesting or complex, if you want to think of it that way, is of course this customer code, because it requires A, it must be unique, B, it has a specific pattern for the characters that are entered into it. And it's not just the pattern of characters, but even the first letter, only certain allowed values, right? So, that was a challenge for people, which is one reason why I'm showing an alternate approach to getting that done, in addition to using an obvious solution, which would be a regular expression, right? So we're just going to walk through the classes, first of all, over in Visual Studio itself, right? So I'm starting with the easiest, the simplest one of them all, okay? And that is our actual lookup value, the function type, right? There's really just two properties in here for the most part, right? The primary key, which following the naming convention we have, it could either be the class name with ID at the end or just ID, and the system will automatically assume that that's going to be our primary key. I don't have to put any annotations like key or anything like that on it, right? And using an integer, it will automatically create an integer identity primary key, and that's our default for most of our entities. Then I simply have a name, of course, using data annotations. We talked about these, that it's better to use data annotations with this approach, this code first approach to MVC design, because it gives not only information to, as we build the database in terms of what's required or what's not, maximum lengths, anything else that can be set as a property in the database design, and at the same time, it provides information used in the user interface, whether the display name gives us a nice label, right? And then, of course, our error messages can be used with the built-in JavaScript validation that is part of modern web browsers as well, right? So we get our own custom error messages showing up for the most part right in the user interface, even without it having to post back to the server. It can just run locally on the client device, right? So a very, very good way to do our validation. Much better than playing around in the setter of the property, because then it only works in that one location, doesn't communicate the error messages very effectively down to the end user. And of course, the other thing we do have in here We often call these navigation properties, right? And that in this parent, we're having a collection of the related child objects, the functions that are of this particular function type, right? Okay, so let's look at the customer next. In the customer object, right? Notice I'm going to come down here to the bottom. First of all, point out that we have the exact same line of code in here, right? Because it as well is a parent to the function entity, right? So we have that same navigation property here, that collection. Now you can create this application without these collections in the parent, but what does it do for us? What command are we allowed to utilize? Anyone remember? When we do a link query in our code, having these properties in the parent object allows us to do that .include, right? So we can automatically include, and that way it populates these collections. So for example, inside customer, we can include all the functions for that customer. And then that collection of objects is stored right inside the parent object, the actual customer itself. Of course, in SQL, that actually just creates a join between the two tables, right? And gets all the data where there's values that match across the join. In other words, all the functions for the customer and so on. Okay. All right. So getting back up to the top here then. Now, this is not in the posted code. This is part of that extra text file that I put up that I mentioned a moment ago. The idea was that I wanted to share an alternate approach to getting around the validation restrictions we're going to have on our customer code. Because some people just have a really hard time with regular expressions. And I understand why, right? Regexes are kind of like speaking Martian, right, to some degree. So, this is something that can really help with that. All right, so again, we have our integer identity primary key. We'll come back and talk about summary properties in a minute. But you notice my first, middle, and last name look familiar? Right out of the medical office example, right? No big deal there. Difference with the company name. The company name is nullable, right? So we do not have the required attribute, okay, on the company name. Oh, by the way, I had a great question from the class earlier this morning about the data annotations. The student got, frustrated for hours and hours trying to get their things to work properly. And what they discovered is they forgot to put the annotations above, above the property, right? It's a common mistake. I've even done it myself, and then it took me a few minutes to realize what had happened, right? But yeah, the annotations describe the property, or they're added to the property below, right? So very important that the annotations are sitting above the actual property you're applying them to. Okay, so we don't have a required attribute for the company name because it is not required. Mind you, if it is entered, we're setting the maximum length to 120 characters. Okay, now the phone number is nothing new, same as we did in our medical office example, right? We can store a phone number in a numeric data type, but then it requires a very large integer. A standard integer isn't big enough to hold all the characters. So it's a nice alternative. If we use a string, then we can just make sure easily with a regular expression that we have the value. We can set the data type here. And of course, we can add a summary property to show it in a nicely formatted manner. So it's kind of 6 of one, half dozen the other, but in many ways, I find it easier to have it in here as an actual string. All right, so nothing new there, but here's the big one, right? Customer code. Now, what at the moment, I've commented out a regular expression. I could just remove these, okay, and then put this back into action, so to speak, right? And so here's an example of a regex you could use. You could write this in a couple different ways as a regex as well, but basically it's allowing only one of these specific characters. So the fact that they're capital letters, okay, it means just this version of this character. So a capital C, capital G, I, and A, right? Followed by, and by the way, the only reason there's 2 slashes here, like if you look up a regex online, you usually just see 1 slash. Well, that's because as a string in C#, the backslash character has a special purpose. So we need 2 in a row to say, hey, I really mean a backslash here. Thank you. And it would be interpreted as a single backslash, right? So D for digit and 7, right? So this totally works. Okay. This approach is ideal in that it does the job, and it's ideal because it will actually be executable, right on the client inside, looked after by the browser. No need to actually send the data back to the web server for it to be evaluated, right? True client-side validation. Uh, Yes, that's true. If you put the at symbol, okay, then you don't need the double backslash. But this is the way I've usually seen it. And yeah, it's kind of 6 one, half dozen the other. As long as you know your options, that's good. But thank you. I appreciate that. Okay. But, as I said, some students, they just find regular expressions are like talking Martian, right? They just don't want to use them. So I'm going to comment this one back out for now. Oh, I could leave it there, but and we're going to talk in a moment here about the validate. Okay. So the final thing is just our collection of functions, which we already talked about. So by putting in implementing iValidatable object, that automatically adds this validate event, right? So here's just showing one possible approach to doing the same validation, right, using the validate event here. So, you might say in a sense, this is nice in that I can check the two things separately, right? I can first of all check for the first letters. Now, again, you could write this in more than one way. You could, just compare like all four. Is the first character a C, or is it a G, or is it an I or an A, and then have a not in front of all that, right? But this is just kind of a twist on that approach. Here, I'm just grabbing the first character, right? Index 0 for the characters that make up the string, and that's a character, first letter. Then these are my character array of allowed letters, and then I'm taking advantage of index of. Index of with an array returns, actually, is it if it's the first element, then it's index 0, 1, 2, 3. So those are the only choices I have here with 4 actual letters. So we would return 1, 2, 3, 0, 1, 2, 3, but of course -1 means not found, right? So it's one way to quickly check and say, hey, this is not included, right? And the nice thing about this is if I ever wanted to add an additional allowed letter, I just have to come into this array and change it, right? But anyway, so this logic up to here is just checking that first code. So it's kind of nice that I can actually give a separate message to say it must start with one of these letters. Okay, I haven't even looked at the digits at that point. Now, whether you want to just have a else or just do another if is entirely up to you. I decided that I would just show one error at a time, right? So if they don't have one of these letters at the beginning, you're going to get that error. And if it passes this test, then I go on to also check, okay? So here, starting with substring, of course, if it was index 0, it would basically mean take the whole thing, but having the index at 1 skips the first character and then takes the rest, right? And I'm storing that in this string called digits. And then I'm checking there's a not in front of this. So does the length match 7? And digits.all, okay, character is digit, right? So that makes sure they're all digits and then the length is 7. If that's not the case, then I can give a separate message. Invalid customer code, it must have 7 numeric digits after the first letter, right? So it's kind of nice that I can have separate messages for which part of the problem is going on. It's not right or wrong, and compared to the other approaches you could write in here, for example, you could do it all in, a single message, just test everything and give whatever message you want, or have them test separately, but confirm both all in one. So there's multiple ways to do it, or you can go back to using the regular expression. Again, I'll just emphasize advantage of a regular expression, I should really say advantage of a data annotation, is that it can actually be executed on the client. Whereas this validate event only happens when the data is submitted to the server. Now, mind you, if this is the only problem happening on the page, it happens so darn fast, right? They click the submit button and it's going to be back there again. You'd have to blink really, really fast in order to see it or whatever. You know what I'm saying, right? But it does technically make a trip to the server and back in order to get any of this feedback coming. So, my general rule of thumb is if you can get it to work in a data annotation, that's usually the best approach. But I did want to share an alternate approach here. And by the way, if you ever have trouble with things like ranges or anything else, okay, every validation you can think of, right, that you might put in a data annotation could always be done here as well. You can always find some way in C# to do the same thing. All right, so that's basically our three uh, um, actual model classes themselves. Any question about those before we go on? Okay. Well, I'll talk about the summary properties. I mean, these are optional, but they make a big difference in how we can present the information to make it user friendly to the end user. So maybe I'll start with customer here. So I started to do this. I don't always, but just putting a region, it just helps me to hide my code, right? Because I can expand and contract the region. All you do is put the # region, give it a name, and then put end region at the bottom, right? It's just a way to organize your code a little bit. So inside here, I have the full name, formal name, and the formatted version of the phone number, right? Now, there's nothing new here we didn't do in the medical office, but those are the 3 summary properties that I have for the customer. Over here, there's none required for the function type because it's basically just an ID and a name. But in function, I have some summary properties here as well, right? So this is an overall summary for the actual function, right? So here I decided, and this was suggested in the instructions, that you might have and this is in the B part, of course, the instructions. You might start off with the date, okay, and then some information about the duration. Okay, so 1 day, 2 days, and so on. So basically, I'm taking the duration, and if it's greater than 1, right, then I'll say how many days with an S on it is, and so on, right? Then we come over here and we either show the name or the lobby sign. If neither of those are available, then we show TBA, right? This is just using that simple way of doing an if in line, right? Okay, so that's my summary property there. Now, estimated value, that's useful as a summary property, and I can simply calculate that quickly with the numeric values here for the base charge, SOCAN, and then of course the guaranteed number times the price per person. To make it look like currency, I'm just using toString, okay, with C as the argument inside the brackets here. And that gives you my 2 summary properties. And I'm mainly using them, to be honest with you. Well, I had decided to use them on the index. Okay. There's not a right or wrong for the most part about what you show on the index, except as time goes on, you're probably going to want to reduce and reduce and reduce the number of columns on the index and then leave most of the details on, well, guess where? Details, of course, right? Uh, but so I use this on the index, and of course, in the instructions for Part B, it was suggested we might show this when we're going to show that sort of master detail page where we bring up the details for one client, okay, one customer, and then we see all the functions for that customer on the details page. But we'll get to that in a moment. So I just want to finish wrapping up then talking about the different properties that we have here, right? Okay, so I didn't finish walking through all this one yet, right? So let me, a couple more things to mention here. So function, this is the one where besides the summary properties, okay, we have the name and the lobby sign, pointing out that there's no required attributes, right? Technically, you can create it without supplying the name or the lobby sign. I can tell you, working in with people from this industry quite a bit over the years, they never want to be held up from starting a record about something just because they don't have the proper information for that yet, right? That's why it's good to have the TBA, to be announced, show up in our summary until we actually have one or the other or both, okay? Now the date time of when the function is going to be held, okay? Again, we're using this display format. That's mainly here for Chrome, because if you show a date in a date time picker with Chrome, unless it actually has this specific format, it will not display properly when you actually are loading existing data into it. Okay. Now, we're using the range, okay, in order to make sure our days is a greater than 0, right? So the minimum value is 1. What's the maximum value? Well, I mean, if there ever is a proper thing to use based on feedback from the client for a maximum value, by all means use it. If you don't have anything, the unfortunate truth is that range has to have an upper bound, right? There's a lower bound and an upper bound. So that's where often using the data type's maximum value is a quick and easy way to get this to work, right? Again, if you didn't want to use the data annotation, you could do a check inside the validate event. Okay, so the base charge is really just currency. Again, notice we're consistently using display names for almost everything here, unless the actual name of the property is a nice human readable name without camel case, things like that, right? So we have to enter the base charge that's required. Same with the per person charge. Okay, again, currency, et cetera, right? Guaranteed number isn't currency, it's just an integer, right? Making sure the range is at least 1. okay? And that's a good reason why you notice I'm making excellent use of assigning default values. Now, I had some questions from students saying, how come my default values aren't showing up? And I'll talk about that when we get to the actual create process inside the controller. Give you a hint. You actually have to make one of your objects and pass it even to the get for create, right? And that way, by generating the object or instantiating it, okay, all of these values will be set. So same for SOCAN, we're setting an initial value here. Of course, it's currency, et cetera, and has an appropriate required error message and so on, right? Deposit paid. Now, deposit paid is a Boolean as well as no HST and no gratuity. Notice we're setting false as the default values for each and every one of those, right? We don't want to start off assuming they've paid the deposit until we know they have, and only then would we set it, right? Okay, all right. Now we come to the foreign keys. So here we have for the customer, okay? Basically, the most important thing to maintain the relationship is having the customer object in our plain old CLR class. But along with that, we have the integer for customer ID. Naming convention is the name of this class with ID added at the end, so customer ID, and the system will automatically know, oh, that's the actual property in the function class in this case that I'm going to use to store the foreign key value to correspond to the customer's ID, the customer's primary key, right? Okay, now I don't really need a display name on customer because customer works just fine, but I definitely want a display name here. I don't want it to show up with customer ID being generated as the label for the input control on the actual web page, right? So that's why we must have a display name. And because it's a int, not a nullable int, but a real int, if you want to call it that, then make sure we provide our own custom error message for the required attribute here. Okay, now almost a duplication of the exact same process here for the function type. The only difference really here is that we do want a display name for the actual object, the function type object, because camel case, right? We want it nice, human readable and user friendly. Other than that, we just have our two foreign keys. And finally, here's another validate. So in this case, okay, this is probably the best spot to try and do this validation because I have multiple tests to make, right? I basically want to make sure that the function date, okay, isn't before the hotel opened. That's as per the instructions. And then we'll just give an appropriate message. Date cannot be before such and such. And that's that. Or make sure that it's not 10 years in the future, right? And that's as per the instructions we received from our client. Date cannot be more than 10 years in the future. We just don't plan that far out in advance. So no, we aren't going to allow that to happen. So that's just simply working with date, okay, itself using like add years and so on and so forth. Okay, all right. So that's basically it here. And we've talked about the summary properties for all three classes. So I think that that's all we have to really discuss. Again, just before I leave these model classes, I'll emphasize the validate event is fabulous and that you can do absolutely anything in here in C#. The only advantage in the sense of doing data annotations is it can give immediate feedback without ever posting to the client. Any questions before we go on? Either unmute your microphone or put it in the chat. Okay, so we basically got that all done. All right, and we have our error messages, display names, etc. So now we're on to number 2. So there were 15 marks for the actual context, right? And inside the context, we want to make sure we have a unique constraint on the customer code, and the foreign key relationships are restricted from using cascade delete, right? We don't want to delete any of the parents, okay, in relation to the children. So, oh, wrong one. Where's Visual Studio? There we are. Oh, that's the debug. Boy, sometimes it's just easier to point with a mouse. Okay, I'm going to close these up for now. All right, so let's come up to the catering context. Okay, no big surprises here. We have our count them, three DB sets, okay, one for each of our model classes, customers, function types, and functions. Then we come down into the Fluent API where we override on model creating. And here's where we can make fine-tuning adjustments to the objects involved and how they relate and so on and so forth. So I'll start at the bottom. Here is where we add that unique constraint. So this was one of the requirements, that no two customers could have matching or identical customer codes. Well, it's not a primary key, or it would automatically be taken care of, right? But it is a property that has value, so we can actually just add a unique secondary index, right? If we say has index based on customer code, we have the option of saying dot is unique. And in the SQL itself, what you'll see is it's going to create this unique index, secondary index on the customer entity, okay, on the customer code field inside it. And that accomplishes our goal of making sure we have no two customers with the same customer code. Now, of course, what will happen is if we actually try to do that in the database, it's going to what? Raise an error, right? So we'll have to trap that error, catch it, and deal with it properly. But at least the database will look after that. And there's no way for us to know it until we send the data to the database, because there could be hundreds of other users working in the system at the same time we are, and we would never know about it until we try to actually save it. Now, these two chunks of code are doing exactly the same thing, preventing cascade delete, right? So they're both written from the parent point of view, right? So parent is customer is a parent to function. Okay, it's on the one side of the one-to-many relationship, right? I talked about this the other day as well, but basically all the code up to here is doing one and one thing only. It is pointing out or describing what relationship it is we're talking about. Okay, so it's a relationship between customer and function. Now it's currently written from the parent point of view, right? Parent has many children. Okay, parent has many function, right? And then the parent has this property functions contained inside it. That's that I collection with one customer, right? Foreign key is customer ID. And then finally, now we've described what relationship we're talking about. How are we going to change it? We're going to say, no, on delete, we're going to restrict that behavior, right? So there's no cascade delete. Same thing for down here. Now, we could write it from the parent point of view or the child point of view. It's the same relationship both ways, right? It's really this line is what we're actually implementing is this restriction on cascade delete. Okay, so that's basically it. That's all we really need in here. Now, of course, if you try to go ahead and make it at this point, you're going to run into some issues, right? So don't forget, in app settings, okay, you need to have a proper connection string. You can optionally have two separate ones for the security tables, the identity tables, right? But we're just going to throw it all into one database the way we're doing it here right now. And that corresponds to as well what we're doing inside Program.cs, right? So we have our connection string. We're only working with one, so we just have to get the one, and we're using it for both DbContext, application, DbContext, and catering context, right? Remember, this one was scaffolded when we first created the project. It's there for the login system, that security system, and in both cases, we're using SQLite. All right, so that's basically everything we had to do to actually get it up and working, okay? But let's go back to the instructions for a second in Adobe. All right, so implement a migration and create the database. Now let me just talk a bit about migrations. What you're going to see is, here, let me actually get back to Visual Studio. At the bottom down here, I'm calling this method to actually seed the data. So that's also in Program.cs, right? My catering management initializer. Well, where's that? Okay, remember we created that back up here in data, and here's where we do the seeding. So I just want to talk about these lines that we often put at the top of this initializer. This actually will delete the database, and then this will recreate it, right? If you didn't have either of these lines here, it will just try to recreate it if it doesn't exist. You don't even actually have to say ensure created, but what we'll often do is I'll often actually have this commented out, right? Now, I had a student this morning asking, you know what? I found that I had to delete the database every time I made any changes to my model. And I said, that's not surprising. I'll tell you right now, last year, in fact, every year that we've been using SQLite in this course, which is a few years in a row now, to be honest with you, it used to be that there was no hope. If you made any changes to the design of the overall model of the system, you always had to delete the database, delete all your migrations, and start fresh with a brand new migration, right? It was hopeless. So yes, they've made some major improvements so that migrations are much better supported now using SQLite. And so sometimes you get away with actually adding the migration, like a second, third, even fourth, whatever migration, right, without having to delete the previous ones. Less often you can do it without having to delete the database. So, during development, quite often you're going to probably want to delete the database. Just be aware that, during testing then, every time you stop and start, any data you were playing around with entering will be gone, right? So that's why I normally leave it like this unless for some reason I can't add a new migration or update the database, in which case, no, okay, I'll take that out. That's the first thing to try, is just let it delete the database first, right? And then, after you do that, you can try your migration again, right? Uh, and if you really have to, then delete the database and delete all your migrations and start a brand new fresh migration, which is what we did every time last year. All right, enough about that. So here, simple approach. I've just added in my posted example here, 3 different customers. Okay, you might notice the names look familiar from the medical office, but of course I've given company names and a phone number and a customer code. So Gregory House knows the C. This is a company, right, working for Morgan Chase. This is Doogie Howser. It's a government, okay, Agriculture and Agri-Food Canada. And Charles Xavier, I for internal. So he works here at the hotel. He's just arranging something as an internal client, right? Okay, so I just have a couple ones there to seed, a few function types, just a few things that popped into my head for function types. And then finally, of course, after you have to have both those in place, right? So just, think back to what you did in terms of the order you create objects and everything else in the SQL. You actually have to have data in both parents before you can create a related child object, right? So here I'm just going to add one, okay, function for each of my clients is how I've got it set up here, right? So not surprisingly, it's Gregory House who works for the corporate client. Okay, is booking a meeting here, right? And it's JP Morgan Chase, it's a shareholders meeting and so on and so forth. So just some values for the date and the duration. This is a 2 days, the only one that's 2 days, base charge and so on and so forth, right? Charges all the way down through and away we go. Okay, so here's the next one is a internal client, right? So it's just a birthday party that this internal client, Charles Xavier, is holding. And third, but last but not least, this is our government employee, Doogie Howser, has arranged this meeting about food price inflation, right? So just a few values here and there as required. And that's basically it. So what do I have down here? Well, I stuck in a breakpoint as I often do in the catch block. And this is a technique I taught before. In case you have any problem seeding data, this is usually what to do. And then you can examine the EX object as you come through and after you've hit the breakpoint and see exactly what's going wrong, right? It doesn't always tell you everything. Sometimes it does. Sometimes it tells you exactly what the issue is. Sometimes it's a little bit more vague, but it usually at the least points you in the right direction as to where you're going wrong. So I'm going to leave that breakpoint there just in case I actually do run into any problems seeding my data. Okay, carrying right along then, right? So what do we have next? We added our seed data, right, with some sample data. And then I just asked you in the A part here to make controllers, scaffold them, and away you go. And just add some links to the layout page. So maybe I'll just look at that quickly here, coming back once more, right? In our layout page, I was really lazy. I didn't do it fancy yet. We'll introduce some better approaches for the next part. But all I did is I copied and pasted. I got rid of privacy because it's also in the footer, and we just have our controller, functions, customers, and function types. Always the index, because that's where we start when we're dealing with any of these entities. And of course, the names to make them human readable. I put a space between function and types. All right, and that basically wraps up part A. Carry on then to part B, and we'll review that. So here, we had 20 marks for adding code to the controllers, okay? And then 10 marks for that function date property. Now we talked about that already, right? When I was looking at the classes, we already talked about how we use the iValidatable object by implementing that interface. We get the validate event, and basically we're validating that the date okay, if the function satisfies both of these requirements, right? And of course, you're aware that being in the validate event, it actually has to get to the server before it has a chance to do that validation, right? So actually, number 2 is already taken care of in our review of the solution here. And then finally, we're going to look at displaying a list of functions for the customer on the customer details. But let me go back up for a moment to the controllers and the database error handling, right? So let's have a look at that now. So I'm going to come back here. I'm going to close all of this stuff just to keep the screen clean and organized. Did I make a change there? Oh, probably yes, I did. Okay. All right. So coming to the controllers. Okay. Again, I'll start with the simplest function types, right? So here, the main thing I did is, as we talked about, as no tracking, just adds a little bit of performance, right? Because we aren't going to change any of the data I retrieved with this link query. So, why include all the old values along with the new values, et cetera, right? It just is a bit of a performance improvement. But you know what? Later on, we'll talk about the fact that it's also a good thing to have it here because it means that the data returned is a simple iQueryable, right? We'll talk more about that later in the week. Okay, details, right? Here is where, again, I add as no tracking, right? In the link query here. And those two, and then the get for delete, those are the only ones that I worry about that as no tracking. Nowhere else do I incorporate it because usually when we want to make changes, we don't want to have that involved. Okay, now here's my create. Now, there are no default values, right, in the function types to worry about. So a simple create like this, where we return view on an empty object, basically, we aren't supplying an object to the view. So it comes up totally blank. And that's the situation. We'll talk more about when we get to one of the ones, actually, I guess there's only the one, where we actually have default values, why we would take a different approach there. But here it's extremely simple. And then we get to the create. So bottom line to remember about these try catches, it's only when we actually interact with the database. That's when we need our try catch. And as a general rule, in this tool and just about any tool you're using, that's when you usually wrap things in like a try catch or another structure to handle the situation if there's an error. Because databases raise errors, right? And it's outside your code, so you need to be able to catch that and deal with it, right? So that's why we always, I repeat, always modify our code to include something like a try catch whenever we're going to interact with the database. So my try catch here is around the whole process, checking, of course, if the model state is valid, right? And then we try to add it and we redirect back to the index if all goes well. Now, there's not much to go wrong with a function type. It's only a automatically generated ID and a name, right? As long as we validate something is entered in the name, what can go wrong? Not much. So really, we're just covering our bases here saying, well, we'll add a model error because remember the model state gets communicated back to the client, right? If there's any errors. And so we can actually show this on the screen, unable to save changes, la da 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 da, right? Okay, so that's a nice simple one. The edit process, again, nothing much to do here in the get for the edit, okay? Don't even need to worry about our as no tracking. But here in the post, here's where we made the biggest change, right? This is where we incorporate TryUpdateModel. So instead of using like we did with the create here, okay, remember we had our whitelist, sorry, I forgot to mention it. As we went through the create, we have our whitelist to prevent overposting attacks where we're saying only values for this or these, if there's more than one particular properties of our object are going to allow to be updated, right? That's a key thing for overposting attacks. But down here in the edit post, we don't do that because we don't build the object right away, but we do take care of it later on, right? Instead, we go and we get the latest version from the database, right? And then we make sure we actually have it. And down here, try update. We do our try update model, which accomplishes multiple things. We actually pass then, but we have to use a lambda for each one, but we pass a list of all the properties to update. That is essentially our whitelist, okay? That we're accomplishing the same thing we did with that bind expression before. So we have our whitelist. These are the properties we're going to update. So any that came from the database not included in this list will not be touched. And that will become important later on because we definitely will be adding properties that we basically just stay in the database and we don't worry about exposing them to the client, and we certainly don't want the client to be able to directly change any of them, right? Now, the other nice thing about this, by the way, I'll mention it, the TryUpdateModel approach, what it's going to do is when we actually call save changes, the SQL that the tool writes actually compares and decides, no, I'm only going to write my update statement in SQL to update the properties that have actually changed, the fields that are now different, right? Remember back when we learned your standard stored procedures last term, we would write a update procedure where we took a parameter value for every possible field and updated each and every one, even if they didn't change, right? Whereas this time around, using this approach, it's going to be much smarter, and it's actually going to only update the ones that actually have changed. So very, very nice improvement in terms of, it's a micromanaging thing in a sense, but, common sense tells you that right away that's going to be more efficient, right? Okay. And we just call save changes and go back to the index as long as all goes well. Of course, if there is a problem raised by the database, then when we try to do save changes, it will come back and we can catch one or more different types of exceptions, right? We'll be using this later on, I guarantee it, but right now we don't have everything in place for concurrency exceptions. That will come in time. Of course, there might be a DB update exception, but again, I have no reason to anticipate it. There's really nothing that should go wrong for that. So just like we did with create, I'm just going to say, hey, I'm just going to add a model error so it shows up on the screen saying unable to save changes, try it again. And we return our function type to update, the one that we got from the database, we've updated with the data that was sent in from the client. We redisplay that back to the screen. So if they did, make a change, right? The change that they made will be redisplayed again because we're taking the data that they submitted. Finally, okay, delete. Nothing much to do here. Okay, we can add as no tracking. We're free to do so on the get, but on the post, we definitely wouldn't, right? So here we're going to go through, we're going to go get the record from the database. Don't add as no tracking or you won't be able to remove it, right? And then adding a try catch, which wasn't there before, right? Everything went inside the try here that we normally would have done, removing it, saving changes, and going back to the index, right? Catch allows us to look for the actual exception itself, and we're checking for what? We're looking for this, okay, inside the message coming back. Foreign key constraint failed. It's important in this case because, of course, this is a parent with a parent-child relationship, right? Sorry. Oh, sorry, I didn't want to cough in the microphone, but I wasn't quick enough. Apologize for that. Okay. We check for this message to let us know, wait a second, we can't delete this function type because there are functions where it's used in the system, right? And that would be the exception that would prevent us from doing it here because we don't have cascade delete. We restricted that, so we can't delete a function type that is actually being used, right? Now the else branch here is just, hey, we did get a DB update exception. It wasn't this foreign key issue. I have no idea what it was. So again, at least give a message to the user, unable to save changes, and away you go. All right, that's the easiest one. Sorry, I talked a lot of the time through it, but that way I don't have to spend as much time repeating the same type of thing. Let's get to the customers, okay? It's very similar, as no tracking here in index, same thing in the details, right? Create is a simple create view. For the post for create, right? And we're doing the same thing. We have the try catch. This time though, okay, we have a unique constraint. So we're going to look specifically for that. Now I know what it is, right? Because I designed it, right? Now in my medical office example, I just searched for the word unique, okay? That's maybe a little bit lazy because I know that there's only one constraint on the table in that question. So I thought, well, I can just get away looking for the word unique and I'll know exactly what it is because there is only one. Well, what if they make a change down the road? Probably this is a better approach, right? By checking not only for the word unique, but also that it's specifically about the customer code, then with confidence, I can show the error beside customer code adding this model state error and say, remember, you cannot have duplicate customer codes, right? Of course, my else branch, there was some other error message, not this one, right? So you see, in theory, if I had multiple unique constraints, I could check for each one with similar tests like this and give the appropriate message for the specific one if I had more than one. All right, so that's a change from our last one, is we actually have a unique constraint to worry about. Edit's the same process. We just go and we get it on the get, and then on the post, right? Once more, we go and we get it from the database. We don't use the whitelist up here, right? Which we did for the, sorry, I kind of skipped over that, right? For on the create, I forgot to mention, of course, we use our binding expression. Now, oh, you might notice in some of my code, I took out ID, and sometimes I meant to for everywhere, missed it there. Why don't I need it? Because it's the integer primary key, right? We're never going to change it ourselves. So on a create, okay, I don't really need to bind to it, okay? All right, so down here in the edit, that's a small thing. It's not right or wrong, but I usually take it out. Okay, so on the edit post, we don't use the bind, we don't use the whitelist up there. We go get the record, check that we found it, and then once more use our TryUpdateModel, okay? Using these lambdas here to specify all the properties that we do want to allow. So that is essentially our whitelist of changes we're going to allow to be made. We save changes and away we go, okay? Check for a concurrency exception, but once more, right, we have the same thing. On an edit, we might have duplicated the customer code, right? Given them the same code somebody else has. So we have the exact same code here to handle that in the update as we did in the, or the edit, I should say, as we did in the create. Delete, right? Pretty straightforward, same thing. We can add as no tracking here, but not in the post for it. But we do use the try catch, and in this case, okay, we are unable to delete a customer if there are functions for the customer. So very much the same as the other parent, right? The function type. All right, so last but not least is functions, okay? I don't want to run through and bore you by doing all the same things, but here I want to mention, first of all, that we're including, okay, the customer and the function type, right, as well as doing the adds no tracking. The reason for the includes is we want, when we send the function to the screen, we want to have all the data available from all of the related objects, right? So we can show as much information as appropriate on the screen. Down here in details, doing exactly the same here, right? So we have everything that we possibly could need to show. Here's the one you've been waiting for. How do I get the default values to show up, right? Well, basically, even if this wasn't involved yet, but that's for our lookup values. We'll talk about that separately in a moment. But just by instantiating a new function object, right, and then passing that, let me contrast. If I come back to customers here, go back up to the get for create. Remember, this was it here. All we do is we say return view, and not passing an object, it will be null. But here, we're going to actually pass an object. So because we instantiated it, all of those defaults that we set right in the properties of the function object itself, okay, they all get set in this object, this instance of it, and that's what we pass here to the view. So that's why when I go to create a new function, everything that has a default, the values are all filled in, right? A couple students emailed about that issue because they said, hey, I added all these defaults, but they aren't there. Well, you have to actually give an object to the view to work with, then they will be. All right, now, of course, if you don't save it, no big deal. You just made an object in code. You didn't actually save it to the database, right? Now, the other step we're doing here, of course, is we're populating our drop-down lists, right? And away we go. Now, I don't really have to pass the function here, but it doesn't hurt either. Okay, so everything else is the same. We have creates, right? Again, using our try catch. Very simple. There's no other expected database errors, so I don't have to have a huge chunk of code in the catch block, at least not yet. Edit, same thing. Let's just focus on the post again, right? Using TryUpdateModel, we go and we get the function to update. We try update everything that we need to here, and then we save changes and away we go, right? Concurrency, DB update exception. Nothing really to worry about, right? Delete, same process, right? I'll just mention here that in the delete confirmed, Notice that this is nice and simple because there's really no reason we shouldn't delete, right? There's no cascade delete situations preventing us from deleting. This is the child of the family, right? There's no children below this level. There's no grandchildren yet, right? So there's nothing to prevent referential integrity constraint preventing us from actually deleting the function. So that's the blessing that in this case that is a little bit simpler that way. All right, I've been talking a long time now. Let me just go back to the instructions. So that basically finishes off, okay, everything that was required here. Oh, except for this. Okay, sorry, I almost forgot. So on the uh, customer details view, we wanted to show the functions that were there, right? So let me just come back to our controllers. I still have the custom controller open here. So let me come back up to details. I mentioned at the time, okay, that we include the functions, right? So when we do our link query to get customers, include functions. So when we pass this customer object, all of the functions will be populated, created inside this customer, okay, as that I collection internally, right? So that's the only change we have to make to satisfy that last part of the instructions in the controller itself. The rest happens in the view, right? So let's come down here to views, customers, and details. So what do we have here? Well, by the way, you'll notice some consistency in how I've made some changes. Instead of having an H1 at the top, right, that just says details, for example, I usually change things to mention the name of the entity we're working with, so it's a little bit clearer, right? So whether it's customer, function, whatever, you'll always see that I reference that. And I usually make this a little bit smaller. And there's a second H4 usually. It just takes up too much space on the screen. I think it's better to put it together like this. Small point. And it's not something you have to do for marks, right? But I'm just sharing with you the styling that I normally put in place. So this is what we had already scaffolded by the system right down to this point. Then we added this, right? We added an extra pair, a data term or a term description, and then the actual definition, description, value, whatever you want to call it, right? So functions, okay? And then here, what we're going to do is going to put a little table. Yes, I stole most of this code right from the index view and brought it over, right? I'm just going to show two pieces of information about each of the functions for this customer, right? We have that nice summary property, which, it takes any part of the name, label, lobby sign, etc. that's available, combine that with the data information and so on. And of course, pardon me, estimated value, right? We're going to show that as well. So as we go for each, now let me point out this, the model, okay, for each item in model.functions, right? So model is our customer. We only have one, but it contains this collection of functions, and away we go. So for each one, I'm making it a link, right? So notice we actually have to use ASP-controller as well as that action, because the current controller we're generating this code from is the actual customer's controller, right? So if I just said action details, well, it would try to send it to customer details, not functions details, right? And of course, the route ID is going to be the ID or primary key value of this current function, the item, okay, as we loop through, right? And I'm just going to use that summary as what's displayed inside the link and the estimated value beside it, right? You'll notice as well, I usually put like these names back to, instead of back to list, back to customer list or function type list, whatever, right, on each one. Little things like that I always like to change. All right, now we've finished. We've talked through all the instructions. So sorry this is such a long video, but it takes that long. Let's run it now. And we'll just have a look at what it looks like up and running, right? So again, if I go to function types, nice and simple list here, nothing much to this. Although I say like create new, right? Going to details, not much here, right? Unless we're going to actually show related information, there's not much to put on a view like that. Customers, right? So notice we're combining at least the name into this nice presentation of it, the company name, phone number, of course using our phone formatted, and the customer code, right? Details doesn't have too much more except for our related collection of functions, right? So here, each one, this summary, right, is coming together, showing the estimated value, and it's a link, so I can click on it to go to the actual function details. Now, if I go back to function list, then I won't be on the customer list anymore, but I'm in a browser, so I can use this link to go back and away I go. So here I am back again, back to the customer list, and so on, right? There we go, the birthday party, and that's good. Or I can just come directly to functions. So this is what I decided to do. Now, I didn't specify it in the instructions for the lab, so don't worry, you won't lose marks if you have more columns than I do. But I just find that it's really hard to get a good index view layout that doesn't have too much information on it. Usually much of this can go into detail. So that's why my estimated value is, I think, all you really need to see here on this index. And if you want to see how that breaks down, you just go to details, right? And that shows you what the base charge, the per person charge, the guaranteed number, the SOCAN, okay, deposit's been paid, all that information, every detail, as you'd expect on a details view, every detail is shown here. Okay, so that basically is, now I decided to steal an extra line to show the meeting type here rather than having it as a separate column. But that's up to you whether you want to do a layout similar to that. But that basically wraps up everything. No, notice this when I do a create new function, right? Here are my default values, okay? The date, the duration days, these charges, guaranteed number, SOCAN of $50, etc., right? And of course on the create, right? We did talk about this with the medical office example. You want a prompt at the top of any select list, right? So you're telling them, well, I have to select a customer, okay? If I try to save it without that, that's a validation error because that's not a valid value, right? And so we have to select the function type. So it makes it a deliberate choice, okay? They aren't going to create this record and it'll just happen to be the first customer in the list because they didn't pay any attention to it, right? And that's different, of course, from the actual edit process. In the edit process, there already is a value set. So we're going to display the currently set value. If they want to change it, they can change it and away they go. Okay, I think that basically covers everything about the posted solution. Any questions at all? Okay, all right. Well, hang on one sec.